dashboard is fairly daunting, right? So this is an example. Maybe take a moment to look at it and try to figure out what it means or what it represents. So if you have some idea, just park it to the side. And you might want to mentally come back to this point later to see how correct you were. This is a bunch of service requests that were filed with a logistics company. The bubbles you see are different stages of how the request is resolved. The size of the bubble is how many requests were there at each given stage, going from all the way from drafting a request to closing it. And the color represents how long they have stayed in that stage. So the redder it is, that means that at that stage more requests have been pending at that stage for a longer time, and the greener it is means that they have been resolved fairly quickly, or rather they have passed through that stage fairly quickly. Now you see that what is interesting about this is that almost a third of all requests are consistently in the in-progress stage. And then they go, much of them do go over to the completed stage, but they get stuck there. If a request is completed, then why is it not closed? That's one big question that you can draw from this. And the paths that you see are again from, how, what is the volume of requests that goes from one stage to another, and so on. And the colors again mean the same thing, how long they've stayed there. So this is basically a fairly complicated application that we built. This was meant to be interactive. It is interactive actually. And when we had this out, when we delivered this, we figured out that, people were quite clueless about this. People weren't exactly, it's not intuitive at all. This is, if I hadn't given this explanation, there's no way that people could have figured this out on their own, right? So then we started adding text to it, which is something that people can just read, and yeah, if they want to drill down further, then they can always do it. But here's the problem with these sort of dashboards. Let's take a moment to think about what we do when we build dashboards. We have some data, we have some analytics on the data, we think about it, we do a bunch of fairly routine and then maybe, case-specific operations on the data, and then something clicks. I get an insight, I get a nugget or something like that, and I put a widget in my dashboard which reflects that, or at least allows the people to reflect that. Now the problem there is that I'm going from this data set which is fairly ambiguous. I don't know yet what it is. I'm crunching it down into an insight, and then I'm again increasing its complexity back into the dashboard. Because ultimately you want people to have some exploration capability. You can't just put bullet points as a dashboard. That would be just, text. And that can't be a standalone piece of information, because we want clients or any in general stakeholders who is using the dashboard to have some exploratory capability. The problem is that we tend to get carried away with this a lot. Excel is not a dashboard. Excel is where you do the analysis. So you don't want your dashboard to replicate tons and tons of Excel features, because you want the analytics to be restricted in a certain way. So a dashboard has to be simpler than the data it explains. It can't just throw data in your face, where you are just iterating and you're just filtering things endlessly with arbitrarily high complexity. We can't allow that. And the point is that we are giving them some flexibility only so that they can replicate the insights, not the analysis itself. The analysis has to be done beforehand, and it has to lean more towards, prescriptive rather than descriptive analytics. Descriptive analytics can be more or less static, but what is it that you need to do with the data? That is a bigger question that most people want answered, right? So the easiest way to do that is, that's where we're coming from, natural language generation. Maybe directly have a piece of text ready, which is the prescriptive text, which is exactly what I need to say when I'm standing in front of a client and presenting some material or showing some insights through a dashboard. This is an example. It comes from a health survey that was done nationwide, and this is the Uttar Pradesh part of it. Now, all these things, let's say that, so most of the widgets that you see are, let's park them to the side for now, and they are self-explanatory as it is. But there is something that needs to be said, and that is where again the NLG part comes in. And if you see the executive summary, that's what people are most interested in. I'm not sure if it's visible at the end, but I'll read out anyway. It says that based on the latest data refresh of Jan 2019, UP had a composite score of 0.41. Now let's say that 0.41 is some target metric that you're trying to optimize. And best performing indicator is ratio of pentavalent 3 to BCG. Pentavalent 3 is a vaccine, BCG is also a vaccine, and for some reason, for some domain specific reason, the ratio in which they are administered is important, right? And that apparently has the biggest impact on your composite health score. So the next best performing indicator is percent of PW screened for HIV against estimated pregnancy. I'm not a medical person, I don't know what that means. But the idea is that we ought to be able to generate this out of the box with an intent which is provided to you, so that whoever understands this can read this and make decisions based on it. And then there are, you know, some names about which are the best performing districts for the composite score and some which are the least performing districts. Now, the simplest way to automate generation of something like this is to simply use a template. Now, if I wanted to write a simple template to reflect this, then I'd come up with something like this. This is a Jinja, Django, Tornado, whatever you might call it. This is a standard template. And since we are trying to estimate this column called composite score, you can say assume that it's a regression and you can get coefficients of all the factors back from it, and that coefficient is literally just the impact that it has, right? So let's say you fit an estimator and then you have a date which you can format, and then you have a data frame which is your raw data, and then you can do a bunch of different things on it, and that is how this works. But you see, there are, when I actually render this template, there are still tons of problems with it. For example, in the third line from the top, you see the mean that I'm calculating. That can have an arbitrarily high precision. I won't get a 0.41 as expected. I'll probably get a 0.40001 or something like that, right? So it needs to be trimmed. That's one thing. Secondly, in the estimator.features, I'm expecting it to have at least a couple of elements, which may not be true. I could get a dump of data where my estimator is actually just fitting on one factor. So that might raise an index error. So there are a bunch of reasons why the template rendering itself might fail. And I need that to be robust, because this is an application where more and more data is going to keep on coming, and I need to keep on rendering meaningful text without errors, right? So obviously the next thing that I might want to do is make this smart somehow. But the problem is that not everybody can write templates, let alone pandas or Python. And you know, there are templating engines, especially like Tornado and all, which allow you to write arbitrarily complex code within the template itself. So you can write practically any sort of Python code inside a template, which is not what most analysts at least can do. So if I want some analyst to be able to generate this and embed it in a dashboard, I would have to expect them to know not just a little Python. I would expect them to know a fair amount of Python, right? Especially like a lot of pandas, at least pandas and scikit-learn and things like that. So what we tried to do was we tried to automate the template process creation entirely. We just said, you just give us the text. You take your data, you try to transform it, you do whatever it is that you work with. You could do it in Excel, you could do it in Tableau, whatever. Just give it a tabular structure and write some text based on it. We'll generate the template from that straight away. We started guessing the template. Now this process itself has certain assumptions. Every insight that you say about the data, everything that you say about the data comes from some operation from the data or on the data. You have to eliminate all the things that you know from your domain. That is something that comes in later into the picture. But the idea is that if NLG is to work, then all the operations that you, all the insights that you might want to communicate about the data, they have to come from some operation on the data itself. It can't come from a third-party source. Intent can be inferred from the operation itself. So I know that when I'm sorting columns, I'm trying to find out the extremes. When I'm doing a group by, I'm restricting myself to trying to figure out along which dimensions my data has interesting patterns. Or if I'm filtering, then again, I'm only focusing myself on a subset of the rows. So intent to some extent can be inferred from the operation that is being carried out. And of course, like since this is not exactly a machine learning problem, I can just ask the user to give me their intent as well. But that again complicates the process a little bit, because if the user has to keep on doing a lot of manual intervention, then my generation capabilities don't really hold any water. The third assumption is that all operations for the sake of this particular functionality are DIDO, which is data frame in, data frame out. If your output happens to be just like a scalar figure, then let it be a data frame with a single cell in it. Or if it's just a column or a row, let it be a pandas series, but it has to be something compatible. It can't be just an integer or a float. That also can be managed, but it's for the sake of compatibility, it's easier to simply enforce this restriction that all operations are data frame in, data frame out. Just like scikit-learn says array in, array out. I think it does support data frames also, but it still only expects only arrays to be present. And operations need to be present in a parsable logical form. This is the most difficult condition to satisfy. Since you're inferring your intent from the operation, and if the operation itself is not straightforward, if it is something that is just pandas code, or maybe an Excel formula or HTML or whatever it is a nightmare to parse. So it has to be something that is, there have to be very opinionated ways of doing a particular operation, and it has to be concise, right? So in theory, at least, I can say that if I have data, if I have operations on that data, and if I have some representative text which generates this, which narrates some insights about the data, then I can reverse engineer this process to automatically create a template like this one. In theory, this is possible, and to some extent, we've actually done it. So let's see how that happens. For the last two assumptions that we had a component called form handler. So you can think of form handler as data frames for the web. Form handler comes from this package called Gramex. Gramex is an open source platform for building data-driven web applications. And form handler is its primary data model. So it is a way of exposing data through the web and exposing pandas operations through the browser or through HTTP requests. So you can, let me just try and see if we can open that up. Oh, okay, I'm offline. But anyway, so this is something that allows you to do minimal pandas operations, typically not expensive operations, not numerically intensive operations, but typical data manipulation, data munging, slicing, dicing, those sort of operations through the web. So here's an example of it. This data set represents a bunch of sales done in a fictional supermarket. Every row is one sale, right? And let's say that I'm interested in finding out which region here is just west, east, central, and south. Which region had the most sales? So I'm going to group by region and sort the sales column descendingly, right? And then I say, when I get the sorted output, when the grouped and sorted output, I say that the west region recorded the most sales amounting to nearly $500,000, followed by the east and the central regions. That's the insight I draw from it by looking at it. This currently, at this stage, it's not generating anything. This is just the table that you see at the bottom. That is what the analyst looks at and simply types this down. Now what we can do with this information is, as you see, West is a named entity, which is present in my data as some value in a column. Region is an inflected form of the name of a column, right? And similarly, when I say most, that most is an adjective, that comparative adjective that corresponds to an operation that I've done. This time it doesn't depend on data. It depends on the operation. So again, another example of how operations can be used to infer intent. I'm trying to find out extremes, most sales, least sales, things like that. And I say that, okay, in my operations pipe, I have something called sort. So that most probably corresponds to that. And if it was something else, then I wouldn't write most. I'd write something else. Similarly, 500,000 is a humanized representation of this figure. 533 something, 533,000 something, right? I